Thanks, Virginia. Good evening, everyone. I'm really excited to be here. Thank you so much to the organizers and especially UC Davis for putting on this fantastic event. When I grew up in the suburbs of New York City, where my friends all dreamed of one day living in Manhattan. And I cannot tell you why, but my dream was always to live on a farm. And when I finished graduate school, I got married and I moved into my first real home. And it wasn't quite on a farm because that wasn't exactly practical for me, but it was as close as I could get. And I lived right next to a 300-year-old farm in central New Jersey. And then I commuted to Manhattan for my first job. I have spent the past 10 years researching why methane matters and trying to find ways to slow down warming as fast as possible by reducing emissions of methane. And I'm hoping my slides will appear. Pointed that way. Oh, that makes sense. And so if there's anything you take away from my presentation, I hope it's not that I almost live near a farm. I hope it's these 3 points. The first one is that ongoing methane emissions are a major and growing driver of climate change, currently causing around 30% of warming. Number 2, that this warming could be eliminated almost immediately from cutting emissions because methane is short-lived in the atmosphere. And finally, that we have the tools to slash emissions in half, but untapped opportunities remain, particularly in livestock. So it's important to understand that methane is found naturally in the atmosphere, warming our climate. Methane is emitted mostly from the breakdown of organic materials, which are plants and animals, especially in the absence of oxygen. That methane then goes into the atmosphere and it traps heat in the Earth system and prevents it from escaping out to space because it's a greenhouse gas. After around 10 years, that methane is oxidized and it leads to the formation of 3 other greenhouse gases. Tropospheric ozone, also known as ground level ozone, which is different than the ozone layer in the stratosphere. Water vapor, but this time that is in the stratosphere, in the upper atmosphere, and carbon dioxide. And combined, this is how methane is warming the climate. Now, these natural greenhouse gases that are found in our atmosphere, like methane and carbon dioxide, are fundamental for life on Earth. Scientists think that the planet would actually be frozen if they weren't in our atmosphere. So they really are the reason why life on Earth is able to thrive. So methane in the atmosphere has more than doubled from human activities because we are basically providing more opportunities for methane to be formed, but to also escape into the atmosphere. And we are doing this from things like extracting fossil fuels. For example, natural gas is mostly methane, so we are allowing that methane to leak into the atmosphere. We are also raising livestock, we're burying trash in landfills, and so all of those activities are making there be more and more methane into the atmosphere, which is contributing now to more warming of our planet than we otherwise would have had in the natural environment. So these extra and ongoing methane emissions that we're introducing into the atmosphere are contributing to around 30% of the warming that we're experiencing today. Now, methane isn't the only gas or particle that we've been increasing in the atmosphere that is influencing our climate. We actually emit hundreds of different types of gases and particles, and there are a handful of them that are really meaningful for climate. And we actually emit a number of warmers as well as a number of coolers into the atmosphere. The warmers, though, are outweighing the impacts of the coolers. And so right now, we've seen a temperature rise of around 1 degree Celsius above pre-industrial levels. Methane makes up a really large fraction of this warming that we're experiencing. In fact, it's around half a degree Celsius of the warming we experience today. Now, that is second only to carbon dioxide, which accounts for around half of the warming that we're experiencing today. A lot of people are surprised to hear that because CO2 has become synonymous with climate change. But there's a whole other range of climate pollutants, like methane, that are driving this other half of warming. So this is showing you how methane levels in the atmosphere have risen over time. And so you can see that before the pre-industrial era, they're relatively constant. They're contributing to the comfortable temperatures on Earth, but they're not changing Earth's temperatures. But then more recently, we've been driving an increase in these emissions and the amount of methane in the atmosphere. So these ongoing methane emissions, as I said, are responsible for around 30% of today's warming. Here is showing you all of the coolers that we have emitted, and there we go. So those have contributed to cooling the planet, and then we have a whole range of other warmers that we emit. The warming is offsetting, is outweighing the coolers, and methane is contributing around half a degree. And so here is the shares of the current warming from all the climate warmers. So here is where we were with CO2 making up around half of the warming we're experiencing today, and then a whole range of other gases and particles that we emit are making up the other half of warming. Now, a major reason why we need to address carbon dioxide is not because it's the largest share of the pie, but also because it is a long-lived greenhouse gas. It lasts in our atmosphere for decades and even centuries. There is a large fraction of CO2 that can last forever in the atmosphere. So every day we emit more CO2 into the atmosphere, we are causing more warming for generations to come. On the other hand, many of the other warmers are short-lived in the atmosphere, like methane, which means that the moment we stop replenishing the atmosphere with their emissions, we can almost immediately eliminate their warming impact. And this is the potential of methane mitigation. Methane is the fastest way to slow warming, particularly because it's short-lived and because it's the largest share of all of the short-lived climate warmers. There are also many other non-climate benefits to reducing methane emissions. So we can help clean our air because not only is ground level ozone a greenhouse gas, but it also is toxic to plants and animals, and it is the main contributor to smog. So by reducing methane, we can also reduce a lot of ground level ozone. And methane is also an energy source. So methane, as I said, is the main component of natural gas. And so we can capture that methane and then we can use it to generate electricity or heat, and that can help with our energy security. So combined, these benefits lead to improved public health, strengthened food security, and a stronger economy. So if we are to cut methane emissions, there are 3 key sectors that we need to target that are the main sources of human-caused methane into the atmosphere. So there's energy, agriculture, and waste. So the main sources coming from energy are oil and gas, which is basically from extracting and processing and transporting gas, which happens in oil and gas operations. So this is not combustion. And coal mining, which is very similar. Combustion adds a little bit of methane emissions, which is not shown here. The main sources of methane from agriculture are livestock, which is enteric fermentation, as you're all familiar with, as well as manure management, and then also rice cultivation. And then finally, from the waste sector, landfills and wastewater. If we don't act on methane, then projections show that we could nearly double the amount of methane that we're emitting into the atmosphere by the end of the century. And a major contributor to this is coming from oil and gas operations, livestock, and landfills and wastewater. But there are numerous assessments that show that we have the tools available right now to slash methane emissions in half. And again, ignore some of these weird colors on here and just focus on the percent reductions. We have a large number of opportunities from the energy sector. Many of these are affordable, and we also have a large number of opportunities from waste. If we take action to reduce this level of methane emissions, then we could have really powerful climate benefits. So over here on the right is showing the temperature responses to this level of ambition for reducing methane, but over different timelines. So we'll unpack this further. So essentially what you're looking at here is that the top curve on this graph is showing you what we expect methane to contribute to warming, future methane emissions, over the next century if we don't take action. The three other paths are if we do take action, and we cut methane emissions in half, but over different timelines. So there's a delayed approach here where we start cutting emissions in 2040 and end by 2050, one where we're slow, where we started in 2020 and end in 2050, and one that's fast, where we started in 2020 and end by 2030. Now, all of these mitigation paths converge in the long term to reduce warming by around 0.5 degrees Celsius. Now, this is a really powerful number, and it's important to reduce warming in the long term because the maximum extent of warming that we experience will determine how much disruption we have to our coastlines and our habitats and our landscapes and our oceans. And to give you context for how important 0.5 degree Celsius is, you'll recall that I said temperatures have already risen by around 1 degree Celsius, and we're already seeing damages worldwide. Where we are right now with our current policies, we expect to be at around 2.7 degrees Celsius by end of century, and our global targets that are baked into our international agreements are to stay well below 2C, and ideally below 1.5C. And so that 2 and 1.5C, that is the difference of 0.5 degree Celsius of warming. And scientists have shown that if we avoid that additional 0.5 degree warming, we could have 10 million less people at risk from sea level rise, 100 million less people susceptible to poverty, 50% less people exposed to water stress, and 2 times less people exposed to severe heat. These are very meaningful numbers. Now, if we look at the climate benefits in the near term from reducing this level of methane emissions, that's when you really see the value of that fast action, because we could cut warming by around 0.25 degree Celsius by mid-century. And this near-term warming really matters because this is what will determine how fast the climate changes, how bad the extreme weather events get, and how fast they get bad. And so we want to reduce our risks of extreme weather events, and we want to reduce our risks of passing tipping points. And it's also easier for society and for ecosystems to adapt to changes the slower the pace of warming. And so scientists have also shown that this level of methane mitigation can have many benefits to society from its improvements in air quality, which could save hundreds of thousands of lives annually, tens of millions of crops annually, and tens of billions of dollars annually. And so the sooner we reduce the methane, the sooner we see those benefits. So this is now an example of how this level of warming avoided in the long term would break down for the individual sectors. And what really stands out here is this warming that's coming from livestock that we currently don't know yet how to reduce. And so this is an untapped opportunity where if we could find ways to reduce this methane from livestock that we currently don't know how to do, but we potentially could, then we can drive down this future warming even further, which is really exciting and which is why we are all here today. So there's another untapped opportunity in the agriculture sector, and this is nitrous oxide, which is a long-lived greenhouse gas that commits our planet to warming for centuries. And there's another opportunity here for us to innovate and find more ways to reduce emissions so that we can have a safer climate in the long term. So I'm going to end where I began with my 3 key points that I'd love for you to take away from this, which is that ongoing methane emissions are a major and growing driver of climate change, currently causing 30% of today's warming. This warming could be eliminated almost immediately from cutting emissions because methane is short-lived in the atmosphere, and we have the tools to slash emissions in half, but there are untapped opportunities, particularly in livestock. So these are the sources that I used in my presentation in case anyone wants to check them out. Thank you all so much for your time and for sticking with us through some technical difficulties. I'm really excited to see how we can work together to tap into this opportunity and drive methane emissions and thus warming down further. Thank you, guys.